Encryption is already working silently around you right now. When you check your bank balance, when you send a message, when you unlock your laptop, this module makes that visible and shows you where it applies, what it actually protects, and just as importantly, what it doesn't. Because one of the most common security misconceptions I see is about the HTTPS padlock. People think it means a website is safe. It doesn't. And this module exactly explains why. Imagine you need to send a valuable document to someone across the country. You could hand it to a courier and hope nobody opens it on the way. Or you could put it in a locked box, send the box, and share the key separately with the recipient. Even if the courier is curious, dishonest, or robbed, they cannot read the document without the key. That is encryption. It takes readable information and transforms it into scrambled, unreadable noise. Only someone with the correct key can unscramble it back into something useful. Modern encryption is mathematically impossible to reverse without the key within any practical time frame. But the concept is exactly that simple. Encryption is already working silently around you everywhere. When you check your bank balance, when you send a WhatsApp message, when you unlock your laptop. You do not need to understand the mathematics. You need to understand where it applies, what it protects, and what it does not. Encryption appears in two fundamental contexts. Encryption in transit, when data travels across a network from your browser to a website, from your phone to a server, it passes through infrastructure that is not yours. Without encryption, anyone on that path can read it. With encryption in transit, the technology behind HTTPS, the data is scrambled before it leaves your device and can only be unscrambled by the intended destination. This is why the padlock in your browser matters. HTTPS uses a protocol called TLS that encrypts everything exchanged between you and the website. Your login credentials, your payment details, your form submissions, all scrambled in transit, unreadable to anyone intercepting the packets. Encryption at rest, data sitting on a hard drive, a server, or in cloud storage is at rest. Without encryption at rest, anyone who physically accesses the storage medium or compromises the server can read every file. With encryption at rest, the stored data is scrambled and unreadable without the decryption key. Full disk encryption on your laptop, covered in Module 11, is encryption at rest. The two types protect against different threats, and best practice requires both. Standard encryption in transit protects your data from everyone except the platform it passes through. When you send an email via Gmail, Google encrypts the connection between you and their servers. But Google can read the email content once it arrives at their servers, because they hold the decryption keys. This is by design. It allows spam filtering, search indexing, and account recovery. It also means that in a legal proceeding, Google can be compelled to provide your email content. End-to-end encryption is different. The message is encrypted on your device before it is sent. Only the recipient's device holds the key to decrypt it. The platform that carries the message, the server in the middle, never has the keys. It stores and forwards encrypted data it cannot read. Even if the company is hacked, even if a government demands it, the content is unreadable without the recipient's private key, which never leaves their device. Standard encryption, you, the recipient, and the service provider can all read the content because the provider holds the keys. Good enough for most communication. End-to-end encryption. Only you and the recipient can read it. The platform is a carrier, not a reader. Right for sensitive personal communication, confidential documents, anything you genuinely need, kept private from the platform provider. The services that use end-to-end encryption by default: Signal, WhatsApp for messages, iMessage between Apple devices, and ProtonMail. A note on Signal versus WhatsApp, since people ask. Both use end-to-end encryption for message content. The content of your messages is protected in both. The difference is metadata and trust. WhatsApp is owned by Meta, which collects metadata, who you message, when, how often, even if it cannot read the message content. Signal is operated by a nonprofit, collects minimal metadata, and its code is fully open source and independently audited. For most personal communication, WhatsApp's encryption is sufficient. For sensitive or high-stakes communication, journalist sources, legal discussions, medical matters, Signal is the stronger choice. Encryption is a powerful tool with real limits. Understanding those limits is as important as understanding the protection it provides. Encryption protects you from an attacker intercepting your data in transit. A man in the middle on a Wi-Fi network cannot read your encrypted packets. Encryption protects you from someone reading data on a lost or stolen encrypted device. They cannot access the contents without the key. Encryption protects you from a data breach at a company that stored your data encrypted at rest. If the attacker cannot get the decryption keys, the stolen data is useless. Encryption protects your internet provider from reading the content of your encrypted web traffic. Encryption does not protect you from entering your credentials on a phishing site. You decrypt the connection yourself when you log in. The padlock on the fake site confirms an encrypted connection to a criminal server. Encryption does not protect you from malware already running on your device. The malware captures data before it is encrypted, keystrokes, screenshots, clipboard contents. The data never gets a chance to be protected. Encryption does not protect you from a service that holds your encryption keys. If that service is compromised and the attacker also gets the keys, your data can be decrypted. Encryption does not protect your metadata, who you communicate with, when and how often, even when the content is encrypted. Encryption does not protect you from account takeover. An attacker who logs in legitimately with your stolen credentials sees your decrypted data because you decrypted it for them by authenticating. The most important limit to internalize: encryption protects data, not decisions. If you type your password into a convincing phishing site, the HTTPS padlock on that fake site confirms the connection is encrypted and does nothing to protect the credentials you just handed to an attacker. Encryption is a transport and storage protection. Human judgment is a separate layer that no technology can replace. Encryption is only as secure as the key that unlocks it. This is the most consistently underestimated aspect of encryption, both for individuals and organizations. A perfectly encrypted file is worthless to an attacker without the key, and worthless to you too if you lose it. Two scenarios that illustrate why key management matters. Full disk encryption on your laptop. Your recovery key is the backup that lets you access your data if you forget your password. Without it, a forgotten password means permanent, irreversible data loss. Store the recovery key somewhere safe and separate from the device, not in a file on the same laptop. Printed and stored physically, or in your password manager. Your password manager vault. The master password is effectively the encryption key to your entire vault. Most password managers cannot recover your vault if you forget the master password. By design, set up recovery options when you first create the account. An emergency kit, a recovery email, a trusted contact option. The key management principle, stated simply: keys must be stored separately from the data they protect. An encrypted hard drive whose recovery key is stored in a text file on the same drive defeats the encryption. An encrypted database whose decryption key is in the same server directory defeats the encryption. An encrypted zip file sent to a recipient with the password in the same email defeats the encryption. Separate the key from the lock, always. And the practical habits that put everything in this module into daily practice. Check for HTTPS before entering any credentials or personal information on a website. Use end-to-end encrypted messaging, Signal or WhatsApp, for sensitive personal conversations. Standard SMS provides no meaningful security. Ensure full disk encryption is enabled on your laptop and that your phone has a passcode set which activates its built-in encryption. When sending sensitive files by email, encrypt the file itself, a password-protected zip or PDF, and share the password through a different channel, a text message, a phone call, not the same email. Save encryption recovery keys, BitLocker, File Vault, your password manager. Store recovery information somewhere safe and separate from the device it protects. Be thoughtful about what you store in cloud services. Most cloud providers encrypt your data but hold the keys. For highly confidential documents, consider whether cloud storage is the right place at all. Alright, before we move on, here are the 3 things from this module I want you to hold on to. Number 1. In-transit encryption protects data while it moves. At-rest encryption protects data while it sits. Number 2. End-to-end encryption means even the platform cannot read your messages. Gmail encrypts in transit, but Google can still read your emails. Number 3. Key management is the overlooked half. Keys must be stored separately from the data they protect. A key on the same drive defeats the encryption. Before you move, there is one question. A journalist needs to communicate securely with a source. They are chosen between Gmail and Signal. Which offers stronger protections for message content, and why? The correct answer is B. This is the difference between in-transit encryption and end-to-end encryption. Gmail encrypts the connection between you and Google's servers, but Google holds the decryption keys and can read the content. In a legal proceeding, they can be compelled to provide it. Signal uses end-to-end encryption. The message is encrypted on the journalist's device and only the source's device can decrypt it. Signal servers never have the keys. For sensitive communications, that distinction matters enormously. Next up, Module 13. Your data and privacy. See you there.